I'm Ken Johnson. I'm Vice President of Engineering at Opto 22. At Opto 22, we make both software and hardware. Hardware that connects the physical world with networks to allow it to be shared and allow networks and computers to interact with the physical world. And we make software that makes the addition of intelligence to those interactions simple. Say, for instance, the fountains at the Bellagio Hotel in Las Vegas. We make the equipment that connects the computers and controllers to the sensors and actuators and pumps to turn them on at the right time and read values to detect if everything's going okay. We live in a mobile society. People need to access their data from anywhere. So we developed Groov to address that need. Consider a remote asset like a windmill or a solar panel. Groov allows a worker to interact with that asset no matter where they are, receive notifications regarding whether things are going well or not going well. They need to be notified of important events, wherever they may be. A product like Groov provides an interface for personnel, maintenance personnel, to see how the system is running as a whole. Maybe tweak it, maybe turn the whole thing off, turn the whole thing on. The Internet of Things, loosely defined, is the ability for devices to sense and communicate with each other. We've been doing that here at Opto 22, building those for 20 years. You could say it's in our DNA. Our customers make things. What we do is create devices that allow our customers to interact with their things, to automate their things, and allow their things to communicate with one another. Groov is a piece of hardware. It's a small computer running software that makes it simple to build a mobile interface. One of the things that we realize is that panel space is at a premium for our customers. So with the new design of Groov, we've significantly reduced its size so that it takes up less space on a panel. The driving factors to change the design of Groov were to remove moving parts, get rid of the fans, enhance the operating temperature range, and to reduce the cost of assembly.
My name is Kyle Sullivan and I'm a design engineer at Opto 22. I begin designing electronic enclosures by first seeing how many components we're going to have to fit and how the user is going to interface with them. For our products, they have to be easy, reliable, and durable. Autodesk CFD was crucial in implementing a smaller design package for our new Groov product. I was able to use Autodesk Inventor to fully digital prototype the Groov AR1. In that way, we were able to substantially decrease the labor when we actually assembled the product. Integration between Inventor and Autodesk CFD was really nice in that I would just completely digital prototype everything in Inventor, and then when I wanted to run a simulation, I would just click one button and open it in Autodesk CFD, set a few different boundary conditions, and click run, and it was done. The original product had many different pieces, different components, different PCBs, and one of the big design constraints was to simplify the assembly process, the bill of material cost, and the thermal characteristics. The new form factor reduced all of that drastically. So we used the Autodesk CFD early to confirm that it would perform thermally to the harsh conditions our customers require. Because we make everything here in California, labor cost directly impacts our bottom line. By the use of Autodesk CFD, we're able to reduce our labor costs in this product by 70%. So for an electronic enclosure, we have to keep the critical components, or all components, below their junction temperature. And we do that by using Autodesk CFD to prove that our enclosure is going to be able to dissipate the heat we require. We were able to completely remove the two fans from the old Groov by improving the overall thermal performance and design of that product. By using the external chassis of the new Groov to sink the heat, we were able to remove the two fans that we needed in the old Groov. Autodesk CFD saved us money in that it completely eliminated the first prototype run. Instead, we were able to jump into a first initial production run that led to our production product that we're selling to this day.